Okay, now we'll discuss about chapter 2. So I'll open the chapter 2. Okay, network reference model. We'll discuss about in detail about the OSI reference model and TC paper reference model. Okay, so first of all, we'll discuss about data definition, how the data is transmitted, what are the concepts and advantages of network reference model, then what are the different protocols we use, then how do the data encapsulation, decapsulation is done. Okay. The first thing is about the data and the applications. Okay, what do you mean by application? See, every person needs to meet some requirements. Like they want to open a web page, for that they need some application. They want to perform play online game, for that also they need some application. They want to have online video playback recording, video recording, that also we need applications. Okay, so for meeting the requirements of person or people, we need to have some applications. Example, to open a web page, we need HTTP application or HTTP protocol, like that. Okay, along with these applications, more information is generated, like text, pictures, videos. Okay, if you open a website, we can see there will be video, text, pictures. So all information also coming along with applications. Okay, so here data generation. So we need to generate different types of data for these applications. Okay, and there should be transmission of data. So we need to have data transmission between these devices, so that then only the communication will be successful. Okay, so we need to have data communication, data transmission between applications. Okay, then that's the base. Okay, that's not that much important. Okay, now we go for the important thing: network reference model and protocols. Okay, so first one is OSI reference model. They will just tell you how the networks, how the devices are communicating. They will show you the model. Okay, so there are 7 layers there: application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. Okay, each layer is important. Okay, so they will tell you a reference. They will just give you a reference how the network data is being transmitted from one machine or one device to another device. Okay, even if you open a website also from your computer, there should be a reference model based on the reference model. Okay, so remember these layers. Okay, what they will do, and first of all, this is being included in ISO 7489 standard and released in 1984. Okay, and ISO is the one who made this one, and this actually stands for International Organization for Standardization. Okay, they released this OSI model. It's a 7 layer model. So we start from the bottom. Okay, so seventh layer. Okay, sorry, first layer. Okay, layer one, physical layer. Okay, so the seventh one is application. Okay, so physical layer means, it transmit bits between devices. Okay, so the computer understands only bits, no, ones and zeros. So this physical layer actually transmits bits, and they have physical specification like electric level, speed, and cable pins. Okay, how do we transmit the data? It may be in the form of electrical signals or light information or wireless signal, all these things. What about the speed of communication? How many pins are required in the cable? All those things are done by physical layer. Okay, data link layer encapsulate bits into frames. Okay, so data link layer we have switches. Switches understand only, they make only frames, and inside the frame we have data plus MAC address. Okay, that's coming under which one? Data link layer. Okay, so they use MAC address to access the media. Okay, and error checking also done in data layer. So whenever we have, no, we have to check errors in the data, we can use data link layer. Network layer, they use logical address or IP address. In data link layer, we use physical address or MAC address. They are permanent. But network layer, we use logical address or IP address. That is keep on changing. Okay, and we use routers here. And what they will do, they will find the best path for the data to move from source to destination. Okay, routing is done by router, and it is a network layer. They have only IP address, and they have packet as their PDU. And here data link layer contains switch. They will transmit only frames, and they understands only MAC address. Okay, transport layer, we have connection oriented and connectionless communication. Okay, so what is the transport layer now? So when you are opening a browser in your computer, you may open in a browser, no, we will open different window, right? One window we will open email, another window we will open say Google, another window we will open some movie. Okay, we have only one IP address, one MAC address, but we open many applications. So how the network understands which application you opened or which window you opened, no, depends upon port number. Along with each application, you are adding port number. That port number is being added, is done by transport layer, and we call that as segments. Okay. Anyway, here we have to establish connection. Okay. There are two types. We have TCP and UDP. TCP means connection established between sender and receiver before data transmission. UDP means no need to have a establish a connection between sender and receiver before transmission. Okay. So they will be checking error before the transmission of data also. Okay. Then session layers, here we will establish or make or manage or terminate session between entities at presentation. We will establish sessions, connections. Like we have simplex, half duplex, full duplex, no? Okay, those type of communication, those type of dialogue management are done in session layer. Okay. So one-way communication or two-way communication or like those things are done by session layer. Okay. So here we have to send some request and response between applications to establish session. Then presentation layer means whatever data you get from the application layer, yani the user data, user is connected to application layer. So that data should be converted to a form so that the user or the other device or other network should understand. So that type of data encoding, converting data into a coded form and converting that into a secret form. All those conversions, encoding, encryption, compression. Okay. Sometimes the file is too big means we need to compress, reduce the size. Okay. Sometimes we want to encode the data in secret form, like image means JPG form, video means MPG form. Those type of encodings or conversions or compressions are done in presentation layer. Okay. Application layer is the layer where user interacts with the network. Okay. So it provides network service for applications. It is the closest layer for the end user. So maybe someone asks you what is the layer closer for the user in a OSI model? It's application layer. That's the layer where user interacts with the network on the computer. So these layers I explained. Okay. So remember each layer's definition. Important thing is network layer. We have packets. Then it contains IP address. They are used for routing and they have routers. Transport layer, we have segments that contains port number. Okay. Then data link layer, we have frames. They understand only MAC address. Switches are used in that layer. Okay. Now TCP per reference model, though we have 7 layers, although it's like always people feel that OSI model is very complex. So what we have, we introduce a new model, TCP per reference model, and actually that is the main model for internet. Okay, the internet is built upon TCP/IP reference model. Maybe people ask you, TCP/IP model or which model is on which model internet is built upon. So it's based on TCP reference model. Okay, so here we have only 5, 1, 2, 3, 4 layers. Okay, application layer in TCP/IP consists of application, presentation, session layer of OSI application layer. Host to host layer is same as transport layer of OSI model. Internet layer of TCP/IP is same as network layer of OSI model. Network access layer in TCP/IP contains data link layer and physical layer of OSI model. Okay, this is how we compare TCP/IP and OSI. TCP/IP has only 4 layers, OSI has 7 layers. Okay. Then TCP/IP protocols, common protocols. Okay, in application layer, I can use these protocols. Okay, Telnet for remote access, FTP for file transfer, TFTP for trivial or secured file transfer, SNMP for simple network management protocols. Okay, HTTP for website, SMTP for email access, DNS for domain service, domain name service. Okay, when you type the domain name like www.cisco.com or huawei.com, it will be converted to IP address by DNS. DHCP, dynamic host configuration protocol, for getting IP address automatically. So these are the application layer protocols coming under TCP/IP. Transport layer, we have TCP and UDP. How the data will be converted to segments, how we'll add the port number. Before that, no, we want to make a connection between the machines. So this is connection oriented protocol, TCP. So before the data transfer between the machines, no, we should establish a connection between them. There will be acknowledgement. If any packet is lost in the middle, there will be acknowledgement and we can retransmit. But in UDP, there is no acknowledgement, there is no connection establishment, there is no reliability. But this is the fast one because we don't have any reliability, we don't have any acknowledgement or retransmission, but this is slow. But this is reliable. If any packet lost, we can easily find out and we can retransmit. Network layer we use ICMP and IGMP and IP. Okay, so ICMP for ping, no troubleshooting and pinging, internet control message protocol. Okay, IGMP for multicasting. Okay, multicasting, create a group of host machine, group IP like that. Okay, IP for internet protocol. So for assigning IP address for routing data between IPv4 or IPv6, what are the contents inside IPv4 header? All those is coming under network layer IP. Okay. Data link layer, we have three protocols: Ethernet, okay, LAN protocol, PPP, WAN protocol, PPP over Ethernet, also a type of WAN protocol. Physical layer, okay. Now they mentioned in application layer. See, I told you HTTP is used for website access. Okay, web-based applications. You don't want to open a website. Now we need HTTP. Generally, we can have HTML communications. Okay, we can open the HTML pages, or we can send the HTTP get request, set, then post request, put request. All things coming under HTTP. Okay, access various web pages. File transfer protocol for transferring file between hosts. We need whatever I told you in the beginning is there. Just go through that. Okay. Same here, point-to-point protocol. Data link layer contains point-to-point protocol. It works in point-to-point mode. Okay, serial communication. Wide area network. Okay. Okay. Ethernet is a LAN protocol, works at data link layer used in LAN. See, point-to-point over Ethernet, multiple host network remote access through a simple bridge device. Okay, used for broadband dial-up access. Okay, so these protocol names, remember these protocol names coming under common TCP protocol. Application layer, maybe I'll ask you, identify or choose any TCP/IP protocol coming under application layer. These are application layers. The next one is TCP/IP and UD, TCP and UDP are transport layer protocol. Network layer contains three: ICMP, IGMP, IP. Remember these protocol names. Maybe answer the multiple choice question. Okay. Then common protocol standardization organizations. Okay, what are the different organizations? They will set these standards for protocols. No? We have IEEE, we have ISO, we have IETF. Okay, Internet Engineering Task Force. They develop and promote various internet protocols. Okay, different protocols are being replaced or remove the old one done by this organization. IEEE. So, like standards and electronics, IEEE stands for Institute of Electrical and Electronics Engineers. Okay, so in they put standard, they make standards in electronics, electrical, and computer science fields worldwide. Okay, so what type of network we want to create, what type of which one devices we can use, what type of cables, all those things. Okay, ISO is a standardized organization. Okay, like International Organization for Standardization, important role in formulation of compute network standards. Okay, so what type of compute network standards are being needed? They will formulate like OSI model we need, or TCP/IP model, whatever models we need. Who will make these things? ISO. Okay. Application layer. So what I told you, the user interacts with the network or computer by using the application layer. Okay. So here it provides interfaces for application software so that applications can use services. Okay. So here PDUs are called. PD means protocol data unit. Every layer has a protocol data unit. In application layer, it is called as data. Okay. See, application layer data, it contains which application, which protocol you're using. Say HTTP 80, Telnet 23. Okay, FTP, it's port number 2021. Okay, so HTTP provides web browsing. Telnet means remote login. Okay, we want to remotely access a switch or router, we need to configure Telnet. Okay, FTP for file transfer between machines, so we need FTP, file transfer protocol. We have two port numbers 20 and 21. Okay, uploading, downloading, all those things. We need different port numbers. Okay, SMTP, simple mail transfer protocol for mail servers or sending email to the mail server to then receive the email from email server, then to other machine. Everything we need SMTP port number 25. These are all TCP applications. Okay. Then TFTP means simple file transfer, trivial file transfer, so encrypted file transfer. Okay, so that one we have UDP protocol. Okay, and port number 69. Transport layer. Now they discuss about some common protocol FTP. So file transfer between client and server. You have to first establish a connection, then the port number you should give, then you can easily access the upload or download a file from the server. Okay, you can If you want to transfer a file, what you will do, you'll put the file, upload the file into FTP server. Then if another file, another machine want to download me, they will download from the FTP server. That's what FTP, file transfer protocol. Then telnet is remote access. Okay, remotely if you want to access some network device, like from this computer, I want to access a switch or firewall or server or access point or router. I have to configure telnet in these machines. Okay, then there will be some IP address and some passwords from this machine. I can access the device by using telnet command. Okay. Then HTTP, for website access, no, there will be HTTP client. You want to access www.huawei.com, this web page will be available this HTTP server. And when you make the request, no, you'll get the HTML file and it will be converted to the user understandable format. Okay. So here we have get, put, and post functions. Okay. HTTP get, HTTP put, HTTP post. Okay. Transport layer establish a connection between sender and the receiver. There are two things are there, TCP and UDP. TCP means connection, or we have to establish a connection. Then we have TCP. Again, there will be a liability, and if you lost any packet or data or segment, what happened? No, if you lost a data or packet, no, this TCP will make sure that it will retransfer the data. Okay, there is sequence numbering is there, error checking is there. UDP means there is no connection. Okay, simple connectionless protocol. There is no liability, no retransmission, no error checking, nothing. But faster is UDP. TCP is slower. Okay. So whatever data we get from application protocol, it encapsulates the data with transport layer header. And we will add port number. Whenever we have a data in the application layer, the data will be added with port number, and we call it as segment. So in transport layer, the protocol data unit is called as segment. Maybe they will ask you, what is the name of the PDU created in transport layer called as segment? What it contains? Data plus port number. Okay. So this is the header format, the TCP UDP header. Okay, this is TCP header, contains source port number, the port number of the sender, destination port number of receiver where we are connecting, sequence number of the data or segments or packets, acknowledgement number. So whenever you are going for reliable communication, after you send the data or segment, no, we need to get the acknowledgement from the receiver that I received that which one segment or data. Then what is the size of the header? Then reserved for priority service. Okay. Then control bits. We have SYN flag, SYN for synchronization. Okay. To send the data, we need to put SYN flag. To establish connection, SYN flag. Or to close the connection, we have FIN flag. So many flags over there. Window. This one means this will determine how many bytes or bytes of data we can send from sender to receiver. Okay, this window size. Checksum for error correction. Urgent, if you want to send some urgent data, give some priority for video information or which one? No, video or image information, you have to send it high priority means go for urgent. Okay, extra options we can do. Then there's an actual data. This is TCP header format. Total 20 bytes. Okay, for header. Data size will be vary, depends upon the amount of data we have. UDP, we have only 8 bytes in the header. Source port is there, destination is there, length is there, checksum is there. There is no sequence number, there is no acknowledgement number, there is no window size, nothing. Okay, whatever I told here is mentioned here. Okay, so destination source port means whichever computer is sending the data, it's which port they are using for sending. Okay, this is for which to which machines, which port you are communicating, the destination port. Okay, both are 16 bits. Every byte of data sent over the DCP has a sequence number. Okay, it's 32-bit long. Acknowledgement number, whenever they receive a particular data or sequence of data, they have to acknowledge by sending an acknowledgement number. Okay, so I send 5 bytes and they will reply, okay, 5 bytes received, now send the 6th byte. That's the acknowledgement number. Okay. So whatever I told here says SYN control bits are not data. It's actually for sending data, we need to establish some connections, no? And also for closing the connection, we need to have some SYN control bits. That's are called as FIN, ACK, and SYN. Okay. To establish a connection, we need SYN flag. And for replying, no, to acknowledge the data we receive, we need to put ACK flag. FIN means to close the connection, we need FIN flag. Okay. So all these things are coming under here. UDP I already told you. Then TCP UDP port number that I told you. TCP, the transport layer, they will have segments. What containing? Okay, segments contain. Segment is a PD which contains data from the previous layer plus port number. See here, this is my client machine. This is my server machine. I'm using my HTTP. Mine is HTTP client. Okay, that means I want to access a web page from the HTTP server. Okay, so here when I open my browser, I will use the HTTP application. The port number used is my source port number is 1024. Okay, this is my source port number. See, my IP address 111. The what about the HTTP payload? That particular frame or segment actually. Okay, that will contain like this. Okay, so what is contained? The payload contain no source IP, the IP address of HTTP client 111. Destination IP to whom I am communicating 222. What is the port number? My port number is 1024, where I am waiting for the server. Okay, and servers to which port number? Servers which port number are communicating? I want to communicate with TCP port 80 because I want to communicate with HTTP. HTTP means port number 80, so that destination port number 80. This will be sent to the destination. This is what port number. Identify the application which you are communicating. Okay, and here we have two applications. Okay, another one is telnet. In that case, port number is 1231, which I am waiting. That the destination port is 23. So when I am communicating telnet now, the source IP destination IP is same, but the port number will here source will be 1231, destination will be 23, like that. Okay. Now how do we set up the connection in TCP communication? Okay, PC1 and PC2 they want to communicate. As I told you, TCP means a connection oriented session. So before the machines communicate, no, they want to establish a connection. For that we have three-way handshake. So first of all, here we have IP address of source and destination. Source is 111, destination 222. Then TCP header contains sequence number and acknowledgement number. Sequence number means, okay, here I am going to send the first segment with SYN flag set. So SYN flag set means here I have sequence number and acknowledgement. Okay, this is the random number used by the sender. Acknowledgement means 0 because I didn't get the reply from the server. Now after getting this segment, no, he will reply source address. Now I am the source from where destination I am talking to 111 this machine. Now sequence number, this is the sequence number used by who? The receiver, random number. Acknowledgement means A+1 because the reply to the PC1. PC1 send A, so I'm replying. I'm waiting for the next. I'm replying. Oh, I acknowledge that I receive a connection by giving A+1. Then after that, he has to send back third one. So first one, sender will send a segment to PC2. Now PC2 will send back another segment. Okay. Then third one segment will be from PC1 to PC2, source address, destination address, then sequence number. I also received your sequence number and I am acknowledging. Okay, so my sequence number A after A it will be A+1. First segment, then second one. Okay, then acknowledgement is I receive your which one? Sequence number B. That's why I'm acknowledging B+1. Okay, so SYN is set. Here SYN and ACK is set. So here only SYN is there. Okay, here SYN and ACK acknowledge. Then here acknowledgement is going back. Okay, this is what three-way handshaking. Whatever I told you is explained here. Okay, then after that, after establishing sequence number or connection, no, we want to send the data. So whatever data we have, see 1, 2, 3, 4, 5, 6, all the data we will send between PC1 to PC2, and every data send, no, we will increase the sequence number and acknowledgement. So here I will put A+1. Acknowledgement is B+1. Then he will send B+1 sequence number from other side. Acknowledgement is A+1 like that. Okay, so how many packets you are sending, based on that acknowledgement also will come. This is after establishing connection. I will send the data now. Like sometimes now there will be, we need to have sliding window mechanism, okay, to control the data transfer. Sometimes no, PC1 is very faster, but the PC2 may be very slow. So what happens? The data will overflow. Data will be lost in the middle. So what do we need? We need to have TCP sliding window mechanism. Here we will design this PC1 and PC2. They will negotiate and they will make a compromise. How many? What is the size of my buffer, or how many bytes I can transfer or store at a time? Okay. So here I have more data to be sent, like 1, 2, 3, 5, 10, 15 data, or 15 buff. Okay, 15 set of data there to send. Okay, so first I will establish handshake, then I will go for data transmission. When you are transmitting data, what I will do, I will set a new thing called as win. Win means the window size 3. That means I can the receiver can receive only 3 bytes at a time. Okay, the buffer size is 3. So here I send first the sequence number, then window size 3, then SYN flag. So okay, then he will reply his sequence number acknowledgement for this sequence of 100 plus 101. Then he also agree with window size 3. Then flag is SYN and ACK. Then sequence number after 100 it will be 101, and the acknowledgement for the sequence number sent by PC to 201. Then again window size is 3. Then ACK is the reply. After this they will send, see, 101, 102, 103. After that 3 bytes, wait for the reply acknowledgement from which one, PC2. He'll send back acknowledgement 104. Yani I am waiting for the next one, 104. Okay. Now window 1 means send only one frame or one data. Okay, that's what this TCP Windows ready mechanism is showing. Okay, then whatever I told is here. Okay, then four-way handshake shutdown. Now we are going to shut down the connection. Okay, all the data transfer is done. Now I have to shut down the connection. So what I will do, first thing, I want to send the sender has to set FIN flag. Okay, FIN and ACK. Okay, so after that what happened? No, he will reply for your FIN. ACK is set. Okay, then he will set FIN. FIN means finish. Finally, he will send ACK. Okay, so here I will send a connection. I want to close the connection. So I'll set the, whenever you want to establish connection, we'll send the SYN. Whenever you want to tear the connection, disconnect, no, break the connection, will go for FIN flag and ACK. Okay, so sequence number, then acknowledgement, then they will set their acknowledgement for this FIN. Then they will ask you to, they will also close their connection, FIN flag. Okay, I agree means both machines now close the connection. Okay, then next, that is TCP handshake is done. So remember, three-way handshaking, SYN for establishing connection, then acknowledgement for that one, then again you want to send acknowledgement, FIN for closing the connection. In between we have to send the data, and in data we have windows, sliding window, that is depends how much bytes you can send at a time, how much bytes that receiver can store in that buffer. Okay, so network layer is responsible for establishing connection between process and host. They will be responsible for transferring data from one host to another. Okay, so from one machine to another machine, data transfer done by network layer. Okay, and the network layer they use packets. So what does the packet contain? Data plus IP address is packets. And network layer is also called as internet layer. Okay, router is used in network layer. Okay, so what is the function network layer? They provide logical address for network device. Any IP address is given for network devices by the computer. Everyone will get IP address from network layer. They route and forward packet. Okay, there will be different routes in the router. So which route is best one? They will forward those packets to those routes. Okay, they use protocols like IPv4 for assigning IP address for IPv4 machines, and IPv6 for assigning IPv6 address. ICMP, IGMP, I already told you. ICMP for troubleshooting, pinging, establishing connection. IGMP for that multicast communication. Okay, router is used, and the commonly used network protocol is IPv4. Maybe I'll ask you, what is the commonly used network layer protocol? IPv4. Okay, then how the network layer works? See, encapsulate the packet. Whatever data we get from the previous layer, that will be encapsulated, added with IP address, source IP, destination IP, and will become packet. Okay, then it will be followed by the router based on the IP addressing, or which one, the routing table. Every router has a routing table which contains network part and the interface. Okay, whenever you get a packet, the packet will contain source IP, destination IP, and by checking the destination IP, the router will check the table to make sure that network destination address is available in this table. Then in which interface it is connected, you'll forward the data to those particular interface. That's done by router. Okay, then data link layer, here it is between network layer and physical layer. You can check the diagram. Data link layer is between network layer and physical layer. The upper layers are like application, presentation, session, transport network. All these layers communicate with the media, any physical layer, through data link layer. Okay, and the data link layer, see, between network layer and physical layer, provide services for protocol IP and IPsec. Okay, and they will provide all the services for the above layers. And the PDU is called as frame. So here, how do we make the frame? The packets plus MAC address, it will be frame. Whenever we have data or packet with the IP address, no, that packet, when you add MAC address, it will become frame. Okay. So what the data link layer will do? They provide intra-segment communication for network layer, and they will frame. Framing means make the frame out of the packet. How do we make the frame? Add MAC address to the packet or data plus IP address. We will get when you add MAC address, it will become frame. Okay. Physical addressing, and every computer physical means they will understand only MAC address. Error control, so we'll detect the errors in the frames. Okay. Common data link protocols are Ethernet for LAN, PPPoE, and PPP for WAN, wide area network. Okay. Now Ethernet and switch. Ethernet means local area network. Okay. Now it's a broadcast multi-access protocol that works at data link. Okay, it's a broadcast protocol. That's why switches broadcast. Okay, a router will not broadcast. So switch, whenever it gets a frame, it will broadcast. Now, how do the switch works? Switch has a MAC address table. Okay, then that MAC address table, they will store the MAC address of the machine and the port number it is connected. So that whenever the switch want to communicate, no, whenever they send a frame, the switch will open the MAC address table and find out in which particular port the particular destination MAC address or machine is connected. Then they will forward that frame. Okay. Initially they will broadcast. Later on they will not broadcast. They will forward the frame data based on the MAC address table. Now MAC address is physical. Every machine will have NIC card. That NIC card address called as MAC address is permanent. It has two parts: OUI, EUI. OUI part belongs to organization unique identifier from where you bought that NIC card. EUI means a specific or what we call unique MAC address part, extended unique identifier. Okay. Then this one, 6 group of 2 hexadecimal digit. Okay, these are 2 hexadecimal digit. That's why A or F hexadecimal number. Okay, 2 hexadecimal digits. Okay, 6 groups: 1, 2, 3, 4, 5, 6. In between they have hyphens or colon. Okay, ARP. ARP means a protocol which resolve IP to MAC. Okay, so this address resolution protocol discover MAC address for a given IP. See, I am host A, my IP address, my MAC address. I'm host B, my IP address, my MAC address. Okay, this computer want to know the MAC address of this computer. He knows its IP. So what you will do? Make a ARP request. ARP request contains destination IP. For which computer you need MAC address, give that destination IP. So I want to get the MAC address of B. B's IP address is 192.168.1.2. So in A's ARP request, they will mention destination IP as IP address of B. MAC address destination, I don't know, either I will put 0 or FFF. Then once we get the ARP request, it will reply. Okay, to the same machine, source IP. Who is sending? Sending by 192.168.1.2. What is the source MAC address? Okay, my MAC address now 48A4781C, same here. So ARP request means I know the IP address of a computer. I want to know the MAC address. So make the request. In the destination MAC address, we have just put question mark there. We can put 00 or FFF. Okay, because I don't know. Then OSB will reply with its IP address and MAC address. Okay, that's what ARP. See how it is happening. No, they put that full story. You can go through that. The same thing what I told you. Every machine, how do they check their ARP address? Every machine will have an ARP table. How do we check the table? ARP minus A. They will mention that table will contain IP address and MAC address. Okay. So whenever a machine want to get the IP address of another, MAC address of another machine. MAC address of another machine. They will send a ARP request. Then say host one send an ARP request. Host two will reply. Okay. Then host two will send. See, first host two will add an ARP entry. They will check their ARP table with the IP address MAC address. Then host 2 will send the ARP reply. Now what happened? Host 1 will add ARP entry. So whenever you know the IP address MAC address of that machine, they will add in their own table so that next time they can communicate without using ARP. Okay, request, they can communicate without using ARP request, because I got the reply from the host to that my MAC address and my IP. Okay, that I will store in my ARP table, and next time they will communicate by using this table without using ARP request. Okay, that's what how it is working. They mentioned like this. Okay, just go through that. Whatever I told is there. Okay, so you remember what is ARP? Address Resolution Protocol. I know the IP. I want the MAC address means give an ARP request. The other machine will send reply which contain its MAC address. Okay, whenever you are sending ARP request, the destination IP you know, because I know the destination IP of this computer. I don't know the destination MAC address. There you can put either FFF or 000. Okay. Then physical layer, no, it converts digital signal into optical or electric signal or electromagnetic or wireless signal based on physical media. What type of media we have? If you have wireless media between the machines, no, we'll convert the data 10 into wireless signal. If you have fiber optic cable between the machines, no, we'll convert data into light. If you have electrical cable, any copper cable between machines, no, I'll convert the data into electric signal. Okay, so it is a last. See, it is a bottom layer. Okay, it transmits the bit streams on media. It is the one which transmits the bit information in the media. Depends upon media, we have to convert the data. Okay, so here they will discuss about the cables, pins, voltage and interface. Okay, what type of cable, crossover or straight through or WAN cable, like that, everything. What about the pins? Here we have, they will also discuss about the twisted pair cable or optical fiber or electromagnetic wireless signals or not. Okay, then see here, discuss about twisted pair. See, we'll be twisting those pairs of different colors. RJ45 connector at the end of the cable. This is the one which connects to the port, LAN port. Then fiber optic cable, their information sent as light information, and here they have different module for fiber optic cable. And this is for serial connection. Okay, you know that WAN cable, console cable, all those things. Okay, then wireless communication for wireless clients. Okay, the different types of cable, shielded, twisted. By shielded means the covering will be there, unshielded means no covering. Fiber optic means they have only, they will send the data in a faster manner. They will send in light information. That's why we use glass fibers. Okay. Then serial cables for WAN communication between router to router. Wireless, wireless router will send the data to wireless line via electromagnetic signals. Wireless. Okay. Then data communication process. How the communication happens in the sender? The sender will encapsulate the data. Encapsulate means add the header information along with the data. Example, see, I want to access this Quora.com. So this is my data. First, I will add the TCP header and the transport layer. So application layer, we have only data. I want to open www.quora.com. Okay. So at the transport layer, we will add a header, that is TCP header. It's actually port number of source and destination. Then on the network layer again, we will add another header. It's IP header. There we'll add source IP address, destination IP address, and it becomes packet. Transport layer is called a segment. Application layer is data, and the network layer is packet. The data link layer we will add Ethernet header and FCS. Ethernet header means the MAC address part. Okay, source MAC address, destination MAC address. Here source IP, destination IP. Here source port number, destination port number. Then this is FCS, means frame check sequence for error checking. That is done by another data link layer. It's called as frame. Finally, data physical layer converts everything into 1 0, and it will be sent as either electric signal if the media is copper, or twisted pair. It will be sent as light signal if the media is fiber, sent as wireless signal if it is wireless media. Okay, so whatever I told is mentioned here. Remember the PDU names, so protocol data unit names. Application layer, the data PDU is data. Transport layer, the PDU is segment which contains port number of source and destination. Network layer, the PDU is packet which contains source IP, destination IP. Data link layer, we have frames which contain source MAC address, destination MAC address. Physical layer, we contain bits, the PDU's bit binary information. Okay. Now see how the data is moved between networks. Okay. So from computer, we have all the layers, they are represented. Okay. When you go to switch, they will have one, they will focus only on data link, physical layer. Then router, they will add network layer, an application layer. On the other machine, we need to have all layers. Okay. How do we decapsulate? When you reach the other side, they will first remove the Ethernet header and FCS. They will only have payload. When reach there, they will remove the IP header from the packet. Then when you reach the segment or the data link layer, transport layer, sorry, they will remove the TCP error, the port numbers are removed, then finally the data will be coming in the receiver. Like when you are opening, when you send a request for www.cisco.com or huawei.com, you will see only the browser window. You don't know you will not see the content of a packet like IP address. You will not see the content of frame like MAC address. You will not see the content of segment like port number. You will see only the data. So those things added in the sender will be removed in the receiver side. So user will get only data. Okay. This is what coming under chapter 2. So what are the benefits of layered model? So as mentioned here, go through that. Okay. So then what are the common protocols in application layer, transport layer, network layer, data link? So application layer, HTTP for website, FTP for file transfer, telnet for remote access, and so on, means for like a SMTP for email. Transport layer protocols are UDP and TCP. UDPs connectionless, no connection established, no reliability, no retransmission, no error checking. TCP is reliable communication, connection oriented session between sender and receiver. Reliability is there, error checking is there, sequence numbering is there, retransmission is there. Network layer, IP, ICMP, and so on. IP for assigning IP addresses, routing, everything. ICMP for troubleshooting and pinging. Data link layer, we have Ethernet, PPP, PPOE, etc. All these things coming under chapter 2. Hope you understood.